Okay, let's begin. Today we are looking at the first lesson. This is chemistry 1.1, moles and molar mass. Okay, so first, before we start this moles and molar mass, you have to understand the difference between the naming terminology that we use between ionic compounds, and covalent compounds. The ionic compounds, we call them, if you have a metal in this, we call, if any compound that has a metal in it, we call them ionic compounds. And when you have all of them on non-metals, we call them covalent compounds. When you have an ionic compound, we usually call the mass, the weight of the compound as formula mass. There is a reason behind this. And for covalent, we call them as molecular mass. Okay, but generally it is referred both as molar mass for both. Okay, but just to distinguish, okay, because formula ionic compounds usually exist as several units, okay, and covalent molecules usually exist as independent molecules. Okay, so that is the difference. But let's look at how to calculate them. Before we understand this, we have to understand what is a very important thing, what is called as an Avogadro number. Okay, an Avogadro number. Okay, an Avogadro number is something like a unit. Okay, like in chemistry we call 1 mole is a chemical unit. Chemical unit. The chemical term. So if you see 1 dozen, it always means 12. Okay, right? So if you say 1 dozen apples, it always means 12 apples. So when we say 1 mole, it always refers to Avogadro number, which is this number, unique number, 6.022 into 10 to the power of 23. I just make it easy, like 23 just to remember, because this is already a huge number. So if you say 22, 23, it's also fine. If you want to be extremely specific, then you can write 22 into 23. Okay, both will be giving you very close results anyway, answers. So 1 mole is nothing but this many number of particles. If I say I have 1 mole of apple, I have 6.022 into 10 to the power 23 apples. If I have 1 mole of elephants, I have this many number of elephants. This is a huge number of elephants. If I say this many number of ants, I have this many number of ants. Okay, that is the meaning of that. So it's very similar to a dozen, but in chemistry, this number is related because the atoms are very, very small. Okay, how we got this number is you can confine this Avogadro number using different ways. Okay, one of the ways that you can use is to, earlier we saw about the mass spectrometry, where you can identify the isotopes, right? You take the injected sample, you heat the sample, right? So what you do, you take, if you want to find out how many isotopes are there, let's say you want to find out how many isotopes are there in hydrogen, you take hydrogen is hydrogen gas, is H2. So each is going to weigh. So if you look at hydrogen has a mass of 1.008. Hydrogen is a diatomic molecule. That means it always exists as a pair. So if you add another 1.008, it will be 2.016. So if you take 2.016 gram, which will be considered as 1 mole of the substance. So this mole here, having a triangular relationship, 1 mole of any substance of chemical will always weigh its molar mass, and it will contain Avogadro number of particles, which is 6.022 into 10 to the power of 23. So in this case, if you take few examples, if you take hydrogen, hydrogen is a diatomic molecule. So if you take hydrogen, H2, 1 mole of H2 will weigh 2.016 gram, and it will have Avogadro number of particles, Avogadro number of molecules. Okay. But since there are two of them, okay, it is going to have twice the hydrogen atoms. Okay. So here hydrogen is an atom, but since it's diatomic, so this H2, we call this as a molecule. Okay. Usually if there are two atoms, we call them as a molecule. So if you take another example, as simply as, let's take something like water, H2O. So if you calculate the molar mass of H2O, it is going to come as 18. So 18 grams. So 16 plus 2, 18 grams. So the 1 mole is going to weigh 18 grams. It still is going to have Avogadro number of water particles. So how will we find out? So you take any species. Let's take hydrogen 2.06 gram. If you take 1 mole and then you inject the sample, and then when you heat the sample, usually first what happens is the hydrogen is going to break apart, and then it is going to ionize into into gaseous species. It's already a gas, so basically it's going to ionize, and then it's going to form H plus ions, which is going to go over and hit the detector. And we are going to see there are three isotopes that forms. And if we, as I told you, there is several ways to identify Avogadro. We can find out electrolytically, but this was one of the ways that you can find out that if you use 1 mole, you will be able to detect Avogadro number reaching the detector. Okay. Avogadro number. So the reason why I'm giving you a very clear picture is because this number is not a hypothetical number. Okay. So this number is a very valid number. So this number must be known and memorized. Okay. So this number you should know this number, and you should always must not forget this number, 6.024 into 10 to the power of 20. Very important. Now, how to find the molar mass of any substance? So if you go to periodic table, ptable.com, you'll see that for each and every element, you will see, let's look at chromium. Chromium has an atomic number of 21 and a mass of 51.996. So usually in the AP chemistry, they will give you the names also. So let's say that they're talking about chromium chloride or something. They're going to give you that they're talking about chromium chloride. Let's say they're going to talk about antimony sulfide. Okay. And you know that antimony is there, but sulfide is here. So you can find out what's the masses. But this is ptable.com. Okay. But if you look at the periodic table that is given by the AP exam, this period table looks like this. So what is the difference between these two periodic tables? This eventually, if you look at them, this periodic table has names in it, but this one does not have any. So the reason why I'm very clearly telling you now is because you have to know the names of all these elements. For example, K represents potassium, Na represents sodium. So it is not like if you see carbon means first, it's not like first letter represents to the easily identified element by their starting letter. So if you look at Fe represents iron, Sn represents tin, antimony. So you have several things, lead. Okay. So you know several of them are like that, and some of them the molar mass is not atomic mass is not at all given for any of these things. That means they are not going to ask you. So you should be aware of what is this periodic table. So I strongly suggest that at least from 1 to 54 you should memorize that what are the elements names are given. At least you should know the bizarre ones, right? For example, the the antimony, tin, and so on. Which one does not match? Right? Like for example, copper is Cu. It is not Co. Cobalt is Co. Okay, and those. Right? So when writing the formulas also is very important. If you write carbon by an oxygen, if you write like this is carbon. This is carbon dioxide. If you write C, the big O is carbon monoxide. But if you write C with a small o, this is not carbon monoxide. It's an element, cobalt. It's a difference between how you write them. It's okay. So this is like a different way of writing. This is a okay. So let's how to find the molar mass. Magnesium hydroxide and find out what is the molar mass. So if there is no number, okay, since this is there's two oxygens and two hydrogen, two oxygen. So one times the molar mass of magnesium from here, 0.00. Those are the molar mass. If we, we and then the mass will be 58 point. So if you take 1 mole of magnesium hydroxide, will weigh 58, or Avogadro number hydroxide. We can say nothing but 58 grams in 1 mole. Neon. 1 mole of neon mass is given here. 1 mole is going to be ion. If it is an ion, so it is going to be what is the molar? Find out the one. So they're always equal to the okay. Given fraction is right. You're going to remove it. So molar mass. Okay. Has to be cancelled. So 1 mole should be at the bottom. 1 mole of C2H6 should be its molar mass. Okay, so you have to calculate the molar mass of C2H6. So each carbon is 12, 12 into 2, 24, plus 1 into 6, 6. It will be 30.08 gram. Once again, you can cancel moles and moles, and roughly you will end up with 562 grams. Whenever you write the answer also, you have to look at these two numbers. This number has 3 significant digits. This has 4 significant digits. You always go with the less precise. Your answer must have 3 of them. Okay. Please always look at all the fundamentals videos, okay, before you start looking at the AP videos. Okay. Fundamentals and atomic structure is very important. Okay. Now let's look at another question. How many water molecules are there H2? Water molecules, particles. These are particles, water molecules, okay, species, everything is same, okay, are there in 56 grams of water. So the only number, we are going to find out the molecules, okay. So now, whenever you have this, write down 1 mole grams to Avogadro number. When it says molecules, then it's going to talk about Avogadro number, okay. So when it goes like from grams to molecules, it is going to go via grams, okay. So then this is going to have a lot of fences, okay. So you don't have only one fence. If it's from moles to gram, it's going to be one fence. But if it is from moles to grams to Avogadro number, then it is going to have more, okay. So it's always better to be planned, okay. So first let's give some space and then write down molecules of water. So grams of water, and then how to convert grams of water into molecules. So 1 mole of water is 18 gram of water. I just took the molar mass of water. And then 1 mole of water contains Avogadro number of water molecules. So then only as I wrote in such a fashion that I can cancel grams of water, moles of water, moles of water. What is left out is only molecules of water. That's what I want. So I multiply 56 times 1 times Avogadro divided by, if there's nothing, I just put 1. 1 times 18 times 1 will get me the answer, which is 1.9 into 10 to the power of 20. So finding the answer, you should have a step-by-step sequence. Then only it is easy for you. Writing the units are also very important. The next one, if the question is asking you a little further, so it's the same question is modified as how many water molecules. Instead of that, the question is asking you how many hydrogen atoms are there. Here we know that in water molecule, there are 2 hydrogen atoms instead of 1, right? Okay, so that is very important. How many hydrogens are there in the same 56 grams of water? So we will start with the same 56 gram. One mole of water is 18 gram of water. 1 mole of water is Avogadro number for water molecules, but we don't want molecules, we want atoms, right? 1 molecule of water, each of them contains 2 atoms of water. So you have to multiply the previous answer by 2 to get 3.7 into 10 to the power 20. So this is very, very important. So this is the whole thing. So the whole understanding is about how to we talked about how to what is an Avogadro number, okay, and what is the relationship, what is the triangle relationship, how to identify the Avogadro number, how to calculate the molar mass, what is the triangular relationship, and how to do simple problems. If moles, how to convert moles to grams, grams to moles, and molecules, calculate molecules from grams, atoms to grams. So this is the general learning. Okay, this is the essential knowledge that we have learned. Okay, so but as I told earlier in the intro, what is the enduring understanding? Enduring understanding is, can you do problems based on this? Now these questions, this is all standard question, direct questions. But can you solve questions little bit tricky? So in the AP exam, they are going to give you 60 questions and you have to answer within 1.5 hours. So let's take 40 means you're being given 90 minutes for 60 questions, right? So 90 minutes for 60 questions. So you have 1.5 minutes to answer each and every question, roughly 90 seconds to answer each questions. So can we answer these are the questions that you're going to encounter in the exam. Which is a greater mass, 0.25 moles of carbon dioxide or 1.5 to 10 to the power of 23 particles of carbon monoxide? This is the question. So try this for 90 seconds and see whether you were able to do this problem. Which is a greater mass, 0.25 moles of carbon dioxide or 1.5 into 10 to the power of 23 particles of carbon monoxide. I hope you should have done at this point. Okay, this 90-second wait is a very important thing for learning. Okay, so first thing is you should have identified this first one. This one is carbon dioxide, and this one is carbon monoxide. Okay, so those are two different compounds. And first one is asking you to find from moles. It is asking you to find grams. Okay, so first is 0.25 moles. 1 mole of carbon dioxide. It's easy to calculate. 12 and 16 into 2. So it should be 44.01. So now you should calculate, you should get 11 grams of carbon dioxide. Now here you have 1.5 into 10 to the power of 23 particles. 1 mole will have Avogadro number of particles. And 1 mole is going to weigh here 28.01. Which is going to be weigh only 7 grams. So of this, 11 gram is the winner. So carbon dioxide is going to have the greater mass. So this is what the enduring understanding is talking about. So suddenly this question is asking about two different uh, uh, compounds, and then one is asking you to calculate from moles to grams, and another one is particles to grams. So you have to do two different things and then correctly identify the answers. Okay. So the multiple choice are very challenging in AP chemistry. So this is what we call as the enduring understanding. So more practice is needed. Okay. This can be solved only by practicing a lot of problems. Okay. Practicing is the key. Okay, so that's the reason I give you some wait time for you to do these problems. If there is a bigger problem, then I'll give you the answer to see whether you did it correctly and then get follow. Okay, so we'll see for the next class 1.2 next time. I hope this session is very